In the last class, I taught you forming differential equations. Now I'll teach you solving differential equations. Integration of dy is equal to integration of 1 minus cos x by 1 plus cos. How to solve it or how to find general solution? Step 1, d term should not be in denominator. What is integration of dx by root of a square minus x square? Sin inverse x by a equal to 0 by anything is 0. So now tan y cancels here, tan x cancels. Welcome to the session, dear students. Now we'll go ahead with the problems of solving differential equations. In the last class, I taught you forming differential equations. Now I'll teach you solving differential equations. How to solve? So we have different techniques. Now, method of separating variables. I'm teaching you method of separating variables. So exercise 9.4, method of separating variables, or we say variable separable. Method of separating variables, or we say variable separable method. So interesting. Step 1, see to it d terms are in numerator. Step 1, d terms should be in numerator. Should be in what? Numerator. Step 2, functions of x should be with dx and y should be with dy. Functions of x should be with dx and functions of y should be with what? Dy, and t with dt, like that. Then integrate. See, first d term should be numerator, x should be with dx and functions of y should be with dy. Club them or rearrange them. To you can rearrange, you can divide and multiply depending on that. So first target is you should make all the d terms in numerator. Second thing is x functions should be with dx and functions of y should be with dy. If it is t, functions of t should be with dt, like that. Then you should integrate. That's it. This is called as method of variable separable. So dy by dx is equal to 1 minus cos x by 1 plus cos x is a problem they give. So now I told the step. Step 1 is what? D term should be numerator. But here dx is in denominator. So I'll write dy is equal to 1 minus cos x by 1 plus cos x divided by dx. I'll transfer it to RHS. Can I do this? Why? Because step 1 says that d terms dx, dy, d theta, dt, they should be numerator. So this is in denominator. Transfer this so it becomes numerator. Now I've rearranged. Now we can integrate it. Now it is easy to integrate. So now we have dy is equal to 1 minus cos x by 1 plus cos x dx. So integrate both sides. Now variable separable, separated the variables. So integration of dy is equal to integration of 1 minus cos x by 1 plus cos x. So you know 1 minus cos x, integration of dy is y. Integration of dy is what? Y. Integral derivative cancels. Now 1 minus cos x is 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2 dx. Now again 2 cancels. So y is equal to integration of sin square by cos square is tan square x by 2 dx. You know tan square theta can be written as secant square theta minus 1. Can I write it as secant square x by 2 minus 1? All of you know 1 plus tan square theta is secant square theta. Tan square theta can be written as secant square theta minus 1. Now it is in integrable form. So y is equal to integration of secant square x by 2 minus dx minus integration of 1 dx. So you know integration of secant square x is tan x. Integration of secant square x by 2 is tan x by 2 divided by constant, quotient of x. What is quotient of x? 1 by 2. You don't need to do substitution. You know secant square ax is tan ax by a. A means quotient of x. Quotient of x is 1 by 2 minus integration of 1 is x plus c. So now we got the answer. 1 by 2, I'll take it to numerators. 1 by 2 becomes 2 tan x by 2 minus x plus c. So they want you to do what? Solve. Find the general solution. General solution means, so you should convert the differential equation to a normal equation. I wrote it in the form of y is equal to f of x. So it is general solution because we have constant, integral constant. If you know the value of constant, or if they give condition for the constant, then we'll get particular solution. Now we got general solution. We solved the differential equation. Now, second question, dy by dx is equal to root of 4 minus y square, and y value lies between minus 2 to 2. That's the condition they give. Now they want you to solve, or they want you to find general solution. How to solve it, or how to find general solution? Step 1, d term should not be in denominator. So can I write the given problem as dy is equal to root of 4 minus y square into dx, because d term should not be in denominator. I will transfer it to numerator. I have achieved the first step. And second step, functions of x should be with dx, functions of y should be with dy. So now root of 4 minus y square is function of y. So transfer it to RHS because it should be with dy. So dy divided by, bring it to LHS, so it will become root of 4 minus y square is equal to dx. Can I write? Now it is in the form of what? Variable separable. I have separated the variables. Functions of y should be with dy, and d term should be in numerator. So dy is already in numerator, so don't disturb this. So bring this term to LHS, it will become divided by. Now further, dy divided by root of 4 means 2 square minus y square is equal to dx. So now integrate both sides. Integrate both sides. So integration of dy divided by root of 2 square minus y square is equal to integration of dx. It is in the form of integration of dy divided by root of a square minus y square. So it is sine inverse. What is integration of dx by root of a square minus x square? Sine inverse x by a. So it becomes sine inverse y by a, y by 2 is equal to integration of dx is x plus c. Now you can transfer sine inverse to RHS. So I have y by 2 is equal to, sine inverse goes this side, it becomes sine of x plus c. And what is y? Y is 2 times sine of x plus c. That's why they told y should lie between the condition they give, because sine value. So this is the answer. I hope all of you got this. Then dy by dx plus y equal to 1, and y is not equal to 1 they told. Y value is not 1. Okay, fine. Now the given question is dy by dx plus y is equal to 1. I'll rearrange. I'll transfer 1 to RHS. So can I write it as dy by dx is equal to 1 minus y? Now group them. All of you know the rule 1. Rule 1 says that d term should not be in denominator. Transfer it to RHS, it will come into dx. Now bring dx to, sorry, bring dy to 1 minus y to LHS, it will become 1 minus y is equal to dx. So dy by 1 minus y is dx. Dy by 1 minus y is dx. So integrate both sides. Integrate both sides. So integration of dy divided by 1 minus y is equal to integration of dx. All of you know integration of dy is what? Log of 1 minus y, but quotient of y is negative, so minus is equal to x plus c. And you know m log a can be written as log a power m. I can write power minus 1 is equal to x plus c. Or I can write log of 1 divided by 1 minus y is equal to x plus c. Now take e power on both. This is log e, transfer that side. So 1 by 1 minus y is e power x plus c. Or rearrange 1 minus y is equal to 1 by e power x plus c, and you can make y as subject. Y is equal to 1 minus 1 by e power x plus c. Further you can also rewrite it. I can write it as 1 minus, if I split this, e power x into e power c. 1 by e power c is a constant, so e power minus x into k. Or you can leave it here, not an issue. So no need of simplification, you can leave it here. Next, secant square x tan y dx plus secant square y tan x dy. So now dx is in numerator, dy is in numerator. But functions of x should be with dx, this is proper, but tan y should not be here. So here tan x should not be here. So divide both sides by tan x into tan y. Divide both sides by tan x into tan y. So this will become secant square x tan y dx divided by tan x tan y plus secant square y tan x dy by tan x tan y equal to 0 by anything is 0. So now tan y cancels here, tan x cancels. So what is left out? We are left out with secant square x by tan x dx plus secant square y by tan y dy. Now integrate both sides. If you integrate both sides, it will become integration of secant square x by tan x into dx plus integration of secant square y by tan y into dy is equal to what? 0. All of you know very well integration of f dash x by f of x. Integration of f dash x by f of x dx is log of denominator, log of f of x. Means if plus c. See, means if numerator is derivative of denominator, answer is log of denominator. Now this is in the form of f dash x by f of x. What is derivative of tan x? Secant square x. So it is in the form of integration of f dash x by f of x. So it will be log of f of x, log of tan x plus log of tan y is equal to, so plus constant, I will write RHS as log c. See here it is interesting, it is 0, but here plus c I will write, c I will take that side, it will become minus c. Any number can be written as log of number. So I wrote like this. Now log a plus log b can be written as log a into b. Log tan x into tan y is equal to log c. So now log cancel. So final answer is tan x into tan y is constant. Here so many doubts you will get. So how I wrote this log c? So here when you integrate, we will get plus c. Plus c, you transfer that side to become minus c. Minus c can be written as log of some constant. So that's why directly I call it as log c. So if every term is log, instead of writing constant, you write log constant. That's it. E power x plus e power minus x dy minus e power x minus e power minus x dx equal to 0. So dx and dy are proper. And this is function of x with dy. This is function of x with dy. So first I will rearrange. I will divide or I will rearrange. Can I write e power x plus e power minus x dy is equal to, transfer this term to that side, e power x minus e power minus x dx. This whole term goes that side and dy is proper. This is function of x, transfer it to RHS. E power x e power minus x divided by e power x plus e power minus x dx. Now integrate both sides. So integration of dy is equal to integration of e power x minus e power minus x by e power x plus e power minus x dx. Now integration of dy is y. Now it is in the form of f dash x by f of x. What is integration of f dash x by f of x? Log f of x. See here, put t is equal to e power x plus e power minus x. What is differentiation? dt by dx is derivative e power x is e power x, derivative e power minus x is minus e power minus x, or dt is what? E power x minus e power minus x into dx. So now this will become integration of dt by t, that is log t plus c, that is log of e power x plus e power minus x plus c. That's it. Here you can understand. So the whole negative term I transferred to RHS because dx dy are proper, but here only functions of x are there. So after I transfer that side, this is a function of x, transfer it to RHS, it will become this. Now it is in the form of f dash x by f of x. If you observe, f dash x by f of x, directly you can write log f of x. Integral of f dash x by f of x is what? Log f of x. So now dy by dx is equal to 1 plus x square into 1 plus y square. So can I write dy divided by 1 plus y square is equal to, transfer this side, 1 plus x square into dx. You know the first rule, d term should not be in denominator. I transferred that. This is function of y, I will bring this. Now directly integrate. So it is in the form of integration of 1 by a square plus x square. It will become tan inverse x by a, tan inverse y. This is integration of 1 is x, integration of x square is x cube by 3 plus c. That's it. Simple and direct. Separate the variables. So first rule, dx should not be in denominator, transfer it, it will become numerator, and functions of y should not be with the dx, bring it to LHS, it will become this, and now it is in the form of 1 by a square plus x square, tan inverse x by a, 1 by a square plus y square, tan inverse y by 1, tan inverse y. Integration of 1 is x, integration of x power n is x power n plus 1 by n plus 1 plus c. That's it. Y log y dx minus x dy equal to 0. Here again rearrange. So I'll write y log y dx is equal to x dy. Now functions of y transfer that side. So dy divided by y log y. And x you bring this side, dx by x. Now integrate both sides. Dx by x integration is equal to RHS. What is RHS? Dy by y log y. Dy by y log y. Now you know integration of dx is log x. And integration of this is method of substitution. Put t is equal to log y. Differentiate. So dt by dy is equal to 1 by y. Dt is equal to 1 by y dy. So here we have 1 by y dy. 1 by y dy becomes dt by t. So log x is equal to log t plus c. And see, log x is equal to t. What is t value? T value is, what is t we assume? Log y. Log of log y plus, I told you, if all are log, I'll write log capital C. Now log a plus log b. In RHS, in LHS, I have log y. In spite of writing constant, any number can be written as log of other number. See, now log x is equal to log a plus log b. Log a plus log b is log a into b. Log of log y into c. Now log cancel. So x is equal to log base e yc. Or take exponential both sides. E power x is equal to yx. Or y is equal to e power x by x also you can write. Sorry, it's yc, sorry, yc. E power x yc by c, e power x by c. Or y is equal to some constant into e power x also we can write. Keep rearranging, that's it. So here every term is log. Log instead of c, write log of constant. Log a plus log b is log a into b. So log a into b means log of log y into c. Log cancels. X is equal to log y c. If I want to remove this log, take exponential. E power x is equal to, if log comes this side, it will come e power x is equal to just yc. And we need y is equal to e power x by c. 1 by c is other constant. K's are capitals. Simple. dy, I'll bring this to this side. So y power 5 is equal to minus, let it be, x power 5. So dx goes up and this is 5. Now integrate both sides. Can I write it as integration of y power minus 5 dy? Integration of x power minus 5 dx. Minus I'll write outside. So now y power minus 5 is y power minus 5 plus 1 by minus 5 plus 1 minus x power minus 5 plus 1 by minus 5 plus 1 plus some constant, that is y power minus 4 is equal to x power minus 4 minus of plus constant, or 1 by y power 4 is equal to minus 1 by x power 4 plus constant, and this is by minus 4 by minus 4 by minus 4, multiply by minus 4. So 1 by y power 4 1 by x power 4 minus 4 into c is some constant again. Rearrange it or leave it. You can leave it or rearrange it. So like this. Now dy by dx is sin inverse x. Can I write it as dy is equal to sin inverse x dx? Now it is separated. So integration of dy is equal to integration of sin inverse x dx. Now the game starts. You should be very good in integration. Integration of dy is equal to integration of sin inverse x they want. What is integration of dy? Y. So how to integrate this? Parts. Sin inverse x into 1 dx. Apply parts. What is parts? First function. iLearn says this is first function into integration of 1 dx minus integration of second function into derivative of first function with respect to what? X. Now sin inverse x into, I am using parts. What is parts? First function into integration of second function minus integration of second function into derivative of first function. So integration of 1 is x minus again x. This is 1 by root of 1 minus x square dx. Now do substitution for this. So y is equal to x into sin inverse x. I'll rewrite. First I'll write this, then minus, do substitution. 1 by, I'll take this as 1 minus x square, take it as t. Derivative of 1 minus x square, put t is equal to 1 minus x square. So dt becomes minus 2x, or x dx is minus dt by 2. So this is minus dt by 2. Simplify this. So y is equal to x sin inverse x So minus you take it out, so plus 1 by 2 integration of dt by root t. You know what is the integration of root t? Integration of root t is 2 root t plus c. 2 to cancel, so y is equal to x sin inverse x plus root of 1 minus x square plus c is the answer. So you should know all the type of integrals. So solving differential equation means you have to integrate and get the final equation. General solution means it contains one arbitrary constant or integral constant c. And first is you have to do variable separable. Next, last problem, e power x tan y dx plus 1 minus e power x secant square y tan y dy. So I'll write it as e power x tan y dx, transfer it to RHS, so it will become minus of 1 minus e power x into secant square y dy. Now bring it to LSC, secant square y, this is proper. Tan y, transfer it to RHS, so it will become secant square y by tan y. Separate the variables and bring this to the side, e power x divided by 1 minus e power x minus of minus term also I'll bring this side. So further I can write it as e power x dx divided by if you multiply e power x minus 1 is equal to secant square y by tan y. Now integrate both sides. Integrate both sides. So method of substitution, put this, so it will become log of e power x minus y. This will become log of tan y. I told you, you should not write plus c. If both are log, in the answer is also log c. Now log of e power x minus 1 is equal to log a plus log b can be written as log a into b. It will become log of tan y into c. So log cancels. So final answer is e power x is equal to tan y c tan y plus 1. Or you can write e power x minus 1 is equal to tan y into c, anything fine. Or tan y is equal to, you can rearrange however you want. You can also write tan y into c is equal to what? E power x minus 1, or tan y is equal to e power x minus 1 by c, or tan y is equal to e power x by c is also a constant, minus 1 by c is also a constant, y is equal to tan inverse of, or you can leave it, this is standard. So I hope all of you understood variable separable technique. Please practice all the problems. I'll see you in my next session with some other technique of solving differential equations. Thanks for attending. Thank you.